Okay, so I wanted to show you guys another option for factoring, and this is something that I learned actually from another student once, and I think it's a really cool method to kind of take some of the guesswork out of factoring things that have a coefficient to their x squared. So I'm going to give you a couple examples of just a straight factoring using this method, and then I'm going to give you some that have a GCF actually in common first. So the first example here that I have for you is 5x squared minus 28x plus 15. Okay, and as you can see, if I look at the three terms here, 5, 28, and 15, they have nothing in common, so there's no GCF or greatest common factor that I can take out. So the way I'm going to start this problem, it's a little different. We're going to take this number out in front, 5, and we are going to multiply it times whatever's sitting at the very back of our problem. So what we're going to end up doing is dropping away the 5 in the front. So we have x squared minus 28x plus 75. Okay, so now we're going to factor that just like we were factoring in 6.2. So we're going to put our two parentheses. Going to lead off with x and x. Because this sign is positive, that means that they are the same sign. Because this guy is negative, this is telling us they are both negative, so I'm going to have a minus and a minus. I need two numbers that multiply to 75 and add to 28. So I'm going to start off with 5 and 15. Because I know that multiplies to 75, that's what we just multiplied, so this is going to give me 20. Okay. But that's too small, so I need to actually make my 5 a little smaller, so I'm going to try 3, and I get 3 and 25. And the reason I went with 3 was because I could try 4, but 4 doesn't divide evenly into 75. So 3 is the next number down from 5 that divides into 75. And we would get 28 when we add that. So that means that's our pair. So we have 3 and 25. Now if we stopped right here, our answer would be incorrect, because if I FOILed that out, I would not get back to my original problem. Now remember, at the very beginning, we multiplied here by 5. So we've got to counteract that multiplication. So now we're going to divide by 5. So we're going to say 3 over 5. We cannot reduce this, and this is where the name of this method came from. Because what we're going to do is we're going to do some bottoms up. We're going to take the 5, and we're going to move it in front of that x, bring that bottom up to get 5x minus 3. Now on the second one, we're going to take this guy and we are going to reduce. We always want to make sure we reduce before we do the bottoms up, because if we can, then we have to do that reduction first, or our answer won't come out right. 25 divided by 5 is 5, so we get x minus 5. And there is our answer factored out. We could check by taking those two parentheses, 5x minus 3 and x minus 5, and multiplying them together. Okay, so let's try another one like that. So here's our example number 2. We're going to try 3x squared plus 20x minus 7. So again, the first thing we want to look for is to see if there's something in common. Since 3 and 7 are both prime numbers, there's not going to be anything in common here. So we're going to start off by taking our 3 and coming here and multiplying it times our 7. So we're going to create our new problem, x squared plus 20x minus 21. So now we're going to do our two parentheses. I'm going to lead off with x. Our signs are telling us that our sign, back one here is telling us they're going to be different. This one is telling us our larger number will be positive. So I can go ahead and put my plus and my minus. I need to multiply to 21 and subtract to 20. The reason I'm saying subtraction instead of addition like the previous problem is because I have two numbers that I know are going to be opposite signs, and when I combine or add with opposite signs, I'm actually subtracting. So we're going to get 21 and 1. When I subtract those, I get 20. So there's my pair. My 21, because I remember earlier I told you my larger number needs to be positive, it's going to go first with my plus. The 1's going to go in the back. Again, if I stopped here, my answer would be wrong, because I've got to counteract this multiplication of 3 I did earlier. So now I need to divide both of these by 3. Okay. 21 divided by 3 is 7, so I'm going to get x plus 7. I can't reduce this down, so this 3 is going to come up in front here and make this 3x minus 1. And there is my answer. Okay, now let's try one that has something in common first. So here's our next example, and this is actually an example I got sent through the email. So this is 9x squared minus 51x minus 18. Okay, and I know it doesn't look like it, but all three of these numbers are divisible by 3. So we're going to take a 3 out. That's going to leave us with 3x squared minus 17x minus 6. Okay, so we're going to draw an arrow down here because we're eventually going to bring our 3 back, but for right now we're going to ignore that 3 on the outside that we just took out. And we're going to do exactly what we've been doing with just the inside of this parentheses. So we're going to do the 3 here, and we're going to multiply it times our 6. So that's going to give us x squared minus 17x minus 18. I'm going to do our 2 parentheses. I'm going to lead off with x and x. Again, our signs are going to be different since this back sign is negative, and our larger number is going to be in the negative one. So we're going to do a plus and a minus. We need to multiply to 18, and again, because we're looking at different signs, we have to subtract to 17. So that's going to be 18 and 1. So remember, our larger number needed to go with the negative, so it's going to go in this back parentheses where our 1 is going to go up front with the positive. Again, since we started this factoring by multiplying by 3, that's how we got our 18 at the end. We now need to divide by 3. So this becomes 3x plus 1. And here we can reduce 18 over 3, and this becomes x minus 6. So our answer would be 3 times 3x plus 1 times x minus 6. Okay, let's do one more example like that. So here's our next example. We have 16x squared plus 108x plus 72. Okay, and these do have something in common. They're all divisible by 4. So I'm going to pull a 4 out first, and I get 4x squared plus 27x plus 18. Again, I'm going to draw my arrow down for this 4 that we took out because we're going to ignore him for right now. And we're going to take this 4 inside here and multiply it times our 18. So we get x squared plus 27x plus 72. I'm going to draw our parentheses. Got an x and an x. Because this sign is positive, they're telling us they're going to be the same. And this sign is also positive, so they're telling us they're both positive. So we've got a plus and a plus for our signs. I need to multiply to 72 and add to 27. Now again, I started off with what I multiplied to begin with, which was 4 and 18. But when I add that together, I get 22. So I need to get a little smaller than 4. So the next thing I tried was 2. And I said, what's 2 and 36, which gives us 38. And the only reason I went with 2 is because I knew 2 would divide into 72 because it's an even number, but that's too big. So that means that my number that I'm looking for is somewhere between 2 and 4. Well, the only thing between 2 and 4 is 3. So it's 3 and 24, and there's our 27 that we were looking for. Again, since they're both positive, it doesn't matter where we put them. Now remember, we started by multiplying by 4, so we got to divide by 4. And right here, we can't reduce that, so we're going to bring the bottoms up, and we have 4x plus 3. And on the second one, we can reduce that. That's x plus 6. And remember, we had a 4 that we brought out at the very beginning that I need to write down. And there's my final answer. I hope this helped, and like I said, this is just an additional or an alternative method for you. So if you've been having issue with the trial and error or the grouping method, you can use this on any of those problems in 6.3a, b, or 6.5. You can even use them in the special factorizations for 6.4a. You'll just need to add a 0 in for those difference of squares. And remember, no matter what you're doing, no matter what type of factoring it's asking you to do, the very first thing you always have to ask yourself is there a common factor? You need to pull that common factor out first. Always make sure it is the largest thing that they have in common. So you can always check back in your parentheses and make sure there's nothing in common. And if there is something else in common, that means you did not pull out the greatest common factor. If you have any questions, please give me a holler.